Problem 35, we're going to investigate a polynomial equation for complex numbers. So we have this equation z squared plus I is 0. We want to show the complex number z1, which is negative root 2 over 2 plus root 2 over 2i, satisfies that polynomial equation. So what does it mean to satisfy an equation? It means if you replace z with z1, then you get 0 in this case. That is, the equation is true when you plug in your complex number here. So we need to show that when we use z1 instead of z, namely z1 squared plus I, should be 0. That's what we need to show. So let's compute z1 squared plus I and see that we get 0. We have negative root 2 over 2 plus root 2 over 2i squared plus I. And that's the expression we have to play with. Now, when you square a complex number, you are just multiplying it with itself. I'm going to put a copy next to it. And now, again, we just FOIL. So negative root 2 over 2 times negative root 2 over 2 is, let's see, root 2 squared is 2. 2 squared is 4, so we're going to get 2/4. And then we're going to get negative 2/4 I. Oops. Negative 2/4 I. And then we're going to get also negative 2/4 I for the inside terms. And then for our outside terms, we're going to get an I squared. They're both positive, so the end result will be negative. And then again, root 2 over 2 times root 2 over 2 is 2/4. And then lastly, we have our I hanging out on the side. So I skipped a bunch of steps there. I encourage you to slow down and make sure you followed all of that. We spent a lot of time being really careful with parentheses in arithmetic. So we're going to start to be a little bit less careful, but I encourage you to continue to write parentheses if you need to. The 2/4 here cancels with the negative 2/4 here to give us a 0. And we get negative 2/4 I minus 2/4 I is negative 4/4 I plus I. Negative 4/4 I is, of course, just negative I. And negative I plus I is 0. So if we look at the start of this big computation, we had z1 squared plus I. And if we look at the end of this computation, we have equals 0. So z1 certainly solves that equation. Now, problem 35 actually has a second part, which is find another solution. Namely, we have a quadratic equation, z squared plus I. From all the years we have of working with quadratic equations, we know there's usually two solutions. Occasionally there's just one, but usually there's two solutions. We want to find another solution. How might we guess what another solution is? Well, I know something about the squaring function. I know the squaring function doesn't see negative signs. So, if we looked at negative z1 squared plus I, well, the squaring function kills the negative. We get z1 squared plus I. We just computed that's 0. So it must be negative z1, which is negative root 2 over 2 plus root 2 over 2i, which we can distribute the negative in to make it look like the right form. So root 2 over 2 minus root 2 over 2i is another solution. And let's just highlight that. So we found 2, and later on we're going to see that there's exactly 2 always, but you have to count appropriately.